Okay. Any questions about additions, or today we'll start into free radical halogenation, which will be our last topic.
Can I ask a question that's not quite related to this, but to the class?
Sure.
So the assignment that you gave us at the beginning of the year.
Oh yeah, the resume.
Yeah. Is there somewhere that there's like exact?
Yes.
Okay.
So on Canvas, you should be enrolled in a course called CAS Professional Development. The one that I have, I actually have access to two of them. One for sort of undecided people, but I also have one for chemistry. So if I click on that, this is the chemistry one. Now, before you declare a major, the basically banner and everything is all screwed up in terms of if you indicated that you were interested in biology or chemistry, that's kind of where you go before you formally declare a major. So if I looked at the people, which I can't do for FERPA reasons, but if I pushed the people button, I could see whether or not you are enrolled in this section because you indicated at some point you were thinking about a chemistry major. There's also one of these for biology that I believe Dr. Scheel would be in charge of. So you should have somewhere a College of Arts and Sciences professional development program. If you do not, then I can add you to this one. And in the modules, what you will see is, where's the modules? If you go to the modules section of this, it will have, first of all, what's required is for chemistry, but I think biology, which would apply to a lot of you, is the same. So interviewing is required, and then there's a video on it, there's the submission, there's suggested questions for you to ask. You go through each one of those modules. It's either a handout or it's a video. So for instance, if we look at resume writing, there's a resume writing video, there's a resume writing guide, there are some sample resumes, there's a rubric on which it'll be approved, and then this is where you have to submit your resume on Handshake in order to get it approved. So this is where they have the instructions on how to do that. You can always meet with the career services people, and they will go over it with you as well. So on my end, what I have to do is I have to talk to someone over there and give them the list of all the students that are in the class, and then they will send me back who has had resumes approved. And I haven't done that yet. I was going to do that today, so hopefully by the beginning of next week I will have that taken care of. And then as it comes back, I'll put those into the grade books to show that you've got it approved. If you don't, this isn't the final due date on this will be the last day of finals. So in other words, if you can't, if you haven't started this, you can start this and get it done hopefully, next week. Because there's going to be a backlog of these things, but they know that. And the whole idea of putting this in the class is that way, number one, my objective in this is so that you can get a resume. Many of you have, if you're a COF or an NSF STEM student, you already did this last year. But if you don't have a resume, if you're a sophomore, it's good to have a resume going into the second semester, because then if you're starting to look at internships, you've got one prepared. All you have to do is just keep it updated. Cover letter would be the same way. Now, the cover letter, people have asked, they say about the cover letter, well, what, I have to write it to a specific company or a specific position. Fine. Let's say you wanted to do research at the Cleveland Clinic. Write your cover letter stating that to that. It's not going to go to them unless you send it to them. But, write it for whatever position you would be looking for. You could even write it for, you want to work at something over the summertime that's not chemistry related or not science related. So the directions are here. Allegedly, I can look up who has completed these things, but I can't figure out how to do that. So what I have to do is have their graduate assistant over in career services send me that information, or their assistant, whoever it is. I'm not quite sure who's doing this, but I will send them a list. They will send me back a list saying these people have done these two things.
So, for the resume to be approved, do we have to go to the Career Center, or do we literally just have to upload it to Handshake?
I think you have to upload it to Handshake, and then what they'll do is they'll see it, and then they'll either approve it or they'll give you some feedback. But I have to call somebody. I think I have to talk to Logan, who's the assistant director, and see exactly how he wants to handle this. They were the ones that thought this was a great idea. And the first time we did this, they just weren't prepared for it. So that was my thing too. It's like, oh, you guys thought this was a great idea, but then we can't do it. So last semester I ended up putting it into the spring and giving everybody credit for it, but that's not going to happen this time. So if you have a resume, or if you want to do it, these guides are what help you do this. And all I can do is I can speak for chemistry. Right now, this is not a graduation requirement. In order for this to be a graduation requirement, it technically needs to be approved by the faculty, which is at least a year-long process. And I've been the one who say you can't just make this. Bowler made this all. Bowler did this on their own, but then again, they're Bowler. They can do what they want. Procedures don't necessarily apply to them sometimes. So they made all of this stuff required, and if you have friends in the business school, they have to do a lot more than this. But then again, they do have it as graduation requirement, but yet they're not going to not graduate somebody because they didn't do this. So it gets to be a little dicey, which is why we need to do it the right way, and I've said that, and people hate me for it, but whatever, I don't care. So if you need access to this, if you can't find this, I'll put you in the chemistry one. Does that mean you're obligated to be a chemistry major? Yes, you have no choice at that point. You have to be a chemistry major. No, basically what it means is when you declare your major, what's supposed to happen is that everything associated with your class then gets moved over to your major. But if you're already declared as a biology major, you probably have one of these in biology. If you don't, like I said, tell me. All I do is add you to the class, because it's easier for me to add you. I probably will add you quicker than Dr. Shield will, but it's not a race. But I would say I probably will do that unless I lose your email, and then I still might do it quicker.
And do you need us to do every module, or just resume and cover letter?
So this semester, all I'm asking for is a resume and a cover letter, because that'll put you in shape next semester to apply for internships. I'm thinking that next semester, what I probably will ask to continue the process is, I will probably ask for LinkedIn. I will probably ask that you create a LinkedIn, module, because I know in chemistry that's what we're requiring. So LinkedIn is there. It's how to do it. I mean, once you have a resume set up, setting up a LinkedIn is actually pretty straightforward. And you may say, like I do, like, what's the point of LinkedIn? From my selfish point of view, once somebody has a LinkedIn profile and they keep it up to date, then it makes it easier for me to find out where alumni are. And I have a huge database of chemistry graduates that's the only place where I know where they're working now. And so it helps me keep track of where people are, because people will always ask me, well, how many of your students go into employment? How many of your students go here? And that's the only way I can keep track of it, because no one else at the university does that, including the alumni affairs people. So between a Google search, between a faculty member's Facebook page, apparently they're friends with everybody, that's how I kind of keep track of where the majors are, unless they send me an email and say, hey, I just moved to this company. So from a selfish standpoint, that's why we're asking our majors to be linked in. Now, we have alumni that will say that they've actually been in one position, and because they have a LinkedIn profile, they'll have what are called headhunters, people that are looking to hire people for specific positions. They will go to LinkedIn and find them. And we've had alumni move from one position to another because they've had a good LinkedIn page. So that's probably the only one I'm going to ask for next semester, although I'll think about what. Probably interviewing would come next, but it will be at least LinkedIn, so that way, if you're going to be a chemistry major or a biology major, that in theory you'll have 3 of these things completed. In chemistry, you have to have 5 and 2 electives. And some of the electives you can just do online, and there's a test you take at the end, and that completes the module. So it really depends. And this is all here. I mean, you get a 0 credit class on your transcript when you graduate. That's what the whole CAS professional development is. That's how they track whether you've completed or not. You would get that on your transcript. I doubt an employer is going to look at that and go, oh, they went through professional development. But what you have to remember is, just like homework problems don't pay off immediately, right? They pay off when you take an exam. This pays off because you're going through that process of going through the interviews or mock interviews. You're going through writing a personal statement is on here that you'll have to do for any program or anything that you're going to be involved with after graduation. So we are, as a university, we're not on the cutting edge of the wave on most things. We don't have the kind of cash to be able to do that. But this is one of the things that we're actually way ahead of many other schools in. Between this and the HPAC program and all of that, there's a lot invested that you have to take advantage of, but it's there to help you prepare for, well, what am I going to do, at the end, or to be able to, have a resume ready to go. Because if you're a chemistry major, you'll get emails that say, there's these opportunities or research opportunities, et cetera. Even if you're going to go to the clinic and do research, you still have to meet with the advisor in an interview. So you need to interview, you need to have a resume, probably a cover letter for that. So the earlier you get that, then it's just simply a question of maintaining it. So there is a method, there is a reason. This isn't busy work. What we're trying to do is get you involved with this as early as possible. And like I said, I know students that are in the COF and STEM programs have already done that last year, but what you want to do is keep it up to date. So with coursework, etc.
Does every major have this as required as well? Like if you're not technically a science major, will it carry over to?
I would think that a resume and a cover letter would be required for everybody. But programs were allowed to pick and choose what they wanted. So all I'm aware of is chemistry. That's all I'm absolutely sure of. On the other hand, I know every time I'm in a meeting with this, I point out the fact that many biology majors are fulfilling these requirements because of my class. And say and I say, well, you're welcome to them for that. But if you're in English, all the CAS majors have this. So there's one for English. I think there's one for pre-health. And I'm just not quite sure what the other programs have checked off, but I'm pretty sure a resume and a cover letter would be the first two. And then after that, I'm not quite sure, and I'm not quite sure that I could lay my hands on that master list because I don't even know where it exists right now. Okay. So that's a long answer, but just so you know, I mean, there's a method to the madness. There are very few things that I do just randomly. I have a system that you can't mess with, just like I can't mess with your system, you can't mess with mine. You can make suggestions to it, I'll take those under advisement. But that's why we're doing this. And this is, I mean, there are a lot of schools that don't have anything like this. I mean, when Bowler came out with theirs, some of our majors were like, well, why don't we have that? That was my question. Why don't we have that? So now we have just a mini version of it because we don't have somebody who runs the program, which they have. And theirs is like, clean up your social media, right? So your Facebook page is somewhat professional. They call your phone to see what kind of voicemail message you have. Because that's what an employer's probably going to do, right? Because nobody has a home phone. So they're going to call your phone, and if they don't get you, what kind of impression are they going to get when they get your voicemail message? It says, hey, dude, leave a message. They're probably going to be like, they'll probably look past that, but they do that. And they're interviewing, you go in and interview with a person, and if you don't start well, they send you out in the hallway and you come back in again. So that's, but then again, that's Bowler. So we're sort of piggybacking off their success here, but it is unique for each sort of program. So if you don't have access to it, tell me, send me an email. I will immediately put you on so that you can go through the modules and get these two completed. Okay. So that's a long answer to that, but. Okay. Any other questions? Related or not? Okay. All right, I'll collect up your sheets of topics after. I will give them back. You might want to make sure you have a picture of it, but I will then put together a master list off of what I get from everybody. And I may leave some topics out because I'm like, well, I don't know that I'll ask that question, but certainly I will take the suggestions that you have. So hopefully at this point you're kind of like, number one, either intimidated because it's like, oh my God, this is like so much stuff. It is, but can we tie some of it together? Which is what the chart and the flow chart hopefully help do. I will put some more problems online, although the problem sets that I did move to Monday's class folder, because somebody's like, they were there and now they're gone. Yes, they're moved to Monday's folder. There were a lot of problems there in terms of writing mechanisms, as well as is it regio, stereo, both, or neither. Okay. So if anything comes up, you can, if you don't want to ask, you can always sneak in a message to Piazza. Let's see. I have two questions that I'll either get to at the end or I will answer them. But let's just talk a little bit about free radical halogenation. So my intent is Friday will be a review for the exam. Monday will be the exam. Wednesday we'll finish up anything we have to do on free radical halogenation. and then Friday we'll either finish up that, or I do have, and I think I may have released some review problems for first semester. The first 5 or 6 problems in that set are from second semester. So you'll look at them and go, I can't do these, right, because you haven't had second semester yet. But the rest of them will be good review questions. They'll be similar to the final exam type questions that I will ask you. The final exam questions I have written myself. Okay, it's not an ACS. It's not an ACS exam. If there is one for first semester, I haven't bought it. So it'll just be my questions. So the final sort of topic that we want to talk about is free radical halogenation. And that's in chapter 18 of the textbook. So some of this is going to feed back from the free radical halogenate, or from the halogenation mechanism that we did when we added HBr and peroxide, the mechanism. But let me just introduce the idea here that if you took something like ethane and you added to it chlorine gas, and this can be done either with light or heat, that you're going to end up replacing or substituting a carbon-hydrogen bond with a carbon-halogen bond. So I'm going to end up doing a substitution reaction where I'm going to substitute a CH bond with a CCl bond. And basically I'm going to replace a hydrogen with a chlorine. And then I'm going to, over here with my 2 chlorines that are attached, one of those is going to become that hydrogen. So my product is going to be an alkyl halide and HCl. And there's going to be two reagents we can use. We can either use Cl2 or Br2. They will be different, and we'll get to that and as we go through this. Now, in the overall context of things, why is this an important reaction? And in the old textbook that I used, and the one that Dr. Kwan's still using, it is still in the first semester, so I'm bringing it in now, so that if there's anybody switching, we will have covered most all the topics between him and I. But in the overall scheme of things, alkanes are sort of the mother's milk of organic chemistry, at least as far as what comes from crude oil. So alkanes, a little bit of alkenes and a little less of alkynes, are all what you would find in a sample of crude oil. And crude oil is what we make alkanes from. We might take long chains and cut them up. We might take small chains, make them longer. But if you drove in today, you drove in on a product of crude oil, which is, unless you have an all-electric car, and even then, what powered your all-electric car was probably coal, which is a different mother's milk of organic. That's where the aromatic compounds come from. But crude oil has alkanes, alkenes, and alkynes, and so that's what we use in the refining process. That's what we ultimately use to make plastics and compounds that we're going to use to make whatever we make that's organic. And quite honestly, that's most things. Alkanes, there's only 2 things you can do with them. You can burn them, like I did in my car this morning. Burning an alkane means you react it with oxygen gas, you make CO2 and water. Important reaction, it's what's heating this building right now, but not from a synthetic point of view where I want to make bigger molecules. If I want to take an alkane and make a bigger molecule, what I need to do is I need to replace a hydrogen with a halogen, because now if I have this alkyl halide, what can I do with it? Well, you can answer that question because that's exam 2 and 3, right? What can we do with these alkenes? We can substitute them with OHs. We can make double bonds out of them. Next semester, we'll make triple bonds. We'll convert them to carbonyls. So an alkane itself, I can burn it, great, but I need to put a functional group on it so I can make it bigger. And that's what the alkyl halide does. So free radical halogenation is always going to be our first step to making bigger molecules from alkanes. So that's why it's important. Basically, we're going to do reactions where I'm only going to replace one hydrogen with a halogen atom. In reality, if I did this reaction, more than one hydrogen would be replaced. I'd have a whole mixture of different compounds. So the first thing we should talk about is the mechanism. So in terms of the mechanism of this reaction, what happens? And I will just tell you ahead of time that, dangerously I will tell you, that this mechanism is not going to be one I will ask on Monday, but it would be something for the final before everybody immediately just turns me off, which you probably already did when I said it wasn't going to be on the exam. Then it's like, click. Oh, wait, what did you just say? Don't turn me off, but because I'm going to go over this one time. But in terms of this mechanism, it's going to look somewhat similar to what we did with the alkene plus HBr plus peroxide. And that mechanism could be on Monday's exam. And if you look at older exams, you will see that I have asked that in the past, and I could ask it in the future. So the first thing that happens is my chlorine molecule is going to break apart under the influence of light or heat. And that will make a difference, whether it's light or heat, but let's do the mechanism first, then let's worry about the differences there. So what will happen is, this is what is called the initiation step. I could ask what was the initiation step in the anti-Markovnikov edition, and after everybody paged through their notes, they would go, oh, the two OH groups of the peroxide broke apart to form two OH dots. In this case, same thing's going to happen. My chlorine is going to disassociate with half arrows indicating movement of one electron. My transition state is again going to be the breaking of the Cl-Cl bond. There are no charges in any of this. And so the final is going to be, I'm going to end up with two chlorine atoms. Again, you can call them chlorine radicals, but they're really chlorine atoms. Anything with an unpaired electron is a radical. It's going to be unstable. In this mechanism, I just formed radicals. Once those radicals or those atoms react, they're going to produce another one, which is then going to continue the chain. So in free radical halogenation, these next two steps are called propagation steps, because when you do the first step, it leads to the second one. And so here's what happens. My chlorine dot is going to react with a hydrogen of the ethane, in this case. So my carbon-hydrogen bond is going to break. My H dot is going to pair up with my Cl dot, and the other unpaired electron in the CH bond will go to the CH2. We'll go to that carbon. So this is going to be what's called hydrogen abstraction. This Cl dot is going to take away a hydrogen from a carbon. And so it's going to abstract it. The transition state for this, and I always like to write the hydrogen that's being reacted with the Cl dot or the Br dot. I always like to point it towards it, so that way in my transition state I can say, well, I'm forming a ClH bond and I am breaking an H carbon bond. And so my transition state is going to look like that. Again, the transition state is going to show the bonds that are breaking and the bonds that are being made. So this would be the second step, or this is the transition state that then leads me to forming HCl and a CH2 dot CH3. So now I've just made a primary radical. And is a primary radical stable? It's not as stable as a secondary or tertiary, but am I allowed to write a primary radical? Yes. Right, because it has 7 valence electrons versus the 6 of the primary carbocation. Primary carbocations are still forbidden, but primary radicals are okay. They're not as stable as secondary or tertiaries, but they can be written. So this is perfectly fine. So now what I have is I have a primary radical. So unpaired electron species makes another unpaired electron species. Okay. So next thing I need to do is I need to do the second step in this reaction, which is going to be to take that carbon radical and hopefully this isn't too confusing. I'm going to take it and I'm going to switch it around so it's pointing inside, because now what happens is the carbon radical is now going to react with Cl2. And what's going to happen is I'm going to break my carbon or my chlorine-chlorine bond, and I'm going to take a Cl dot and I'm going to pair it up with the C dot, and then the other chlorine is going to get the unpaired electron. So the transition state for that one is going to look like this. We're going to have a partial bond to chlorine and then another partial bond to the chlorine-chlorine bond. So what I'm doing is I'm forming the C-Cl bond, but I'm breaking the Cl-Cl bond. And so that's going to let me make my final product, which is going to be ethyl chloride, and it's going to make another chlorine atom. So this is the second propagation step, and these are called propagation steps simply because the first step propagates an unpaired electron, and so does the second. So these two steps will continue, because now this Cl dot is going to go back and react with another ethane molecule, which will create another carbon radical, which will react with chlorine, which will make another Cl dot. So this process will just continue until one of two things. We either run out of material, or two unpaired electron species come together, which in this mechanism I'm going to explicitly show. Right, so these are the first three steps of the mechanism. Galen. So here's the thing. In a free radical mechanism, all the chlorine-chlorine bonds do not break. So all it takes is one chlorine atom to break apart. And I now made two chlorine atoms. Every time one of those chlorine atoms reacts, it forms a carbon radical. And every time one of those carbon radicals reacts, it produces another chlorine atom. So if I said, if I looked at this mechanism, maybe 0.01% of the chlorine breaks apart in the initiation step. So not all of it does. And so that's the insidious thing about radicals. Because once you form them, they just keep making each other. They just keep making themselves over and over again. Which is why we talked about when that happens in the body, we need a system to stop that. or else those radicals are going to go around removing hydrogens, again, from DNA and proteins and enzymes and all sorts of things, and that never has a happy ending when that happens, right? My example was you get superpowers, but that's not real. So it always ends up mutations, and mutations are probably never a good thing in the long run, or in the short term, they're probably not good. So we need systems to take care of the radicals. We'll do that later on. We'll talk about that. But so it is, when we think of these mechanisms, we're always thinking every atom does that, or every molecule does that. In this case, very few chlorine atoms break apart, but because of the mechanism, I don't need that. I only need just one. I could get away with one. Okay. All right. Is everybody still kind of with me? So, the last three steps are going to be what are called termination steps. So before we kind of stopped in the addition to the alkenes, we just kind of stopped and said, okay, it's going to continue on until we run out of stuff. But I'm going to actually say, yes, this will continue until we run out of alkanes. And the reality is that once an alkane gets a chlorine, it could be another hydrogen could be removed from it, but we're only doing monochlorination here. But termination means I'm going to bring the unpaired electron species together, and that'll stop the chain. That'll stop the propagation. So the first thing is, what would happen if two chlorine atoms came together? So the two chlorine atoms would each donate unpaired electron. We would go through the transition state, which looks exactly like the transition state to break them apart, because now I'm writing the reverse of breaking them apart. And so two chlorine atoms could come together, and you could form chlorine. Now, these three steps are going to be, I have radical A and I have radical B. So two A's could react, an A and a B could react, or two B's. So this is A and A. What would happen if a chlorine and a CH2 radical came together? If those came together, I would end up forming a carbon-chlorine bond in my transition state, and I would get a molecule of the product that I had already made. So the first termination step is A reacting with A, second A reacting with B. In the third step, it's a brand new product, because what would happen if two CH2 radicals happen to come together? Then what would happen is we would form now a carbon-carbon bond, and we would form a molecule of butane. So if we were looking, if this was a new reaction we were studying and we wanted to find out what the mechanism was, and we proposed this last step, which is what's called coupling, whenever carbon radicals react together, that's called a coupling reaction. I would, in order to validate this mechanism, I would have to do this reaction, and I would have to show that I made some butane. Or more than likely, what would happen is I would do the reaction, I would look at all the possible products that were made, I would see some butane, and I would go, okay, my mechanism's producing butane, what's that mechanism? And I would propose this. So those 3 termination steps we always write for free radical halogenation. And those will also end the process. The amount of product we're going to get into, probably not today, but we'll get into it next week. These 3 reactions are just based on do 2 radicals get close enough together to couple. Because if you're just a chlorine dot floating around, you're more than likely to come into contact with an ethane molecule and react than you are to find any of these 3. So most of the product is still coming. Most of the product is still coming from the propagation step. But it is possible you could get some product from this termination step. And it is possible two ethyl radicals might find each other and couple together. Julia?
Do you have to have all 3 of these to occur to have termination, or just one?
These are the 3 possible ways the reaction could terminate. It could also terminate just simply because we're out of stuff. So, in terms of if I was to ask you to write the mechanism of this, I would ask you to write all 6 steps, including the transition state. And at this point, what I would normally do is I would normally give this as a take-home problem. But since I stupidly said it wasn't going to be on Monday's exam, I'll hold off on that until next week. So that's the mechanism by which the free radical reaction goes. And honestly, that's pretty straightforward. What we want to spend a little more time on is the product. What would be the major product of a reaction? So let me just kind of set that up. And also what the influence of light and heat are. We'll get to that next week. Because there is a difference in the reaction if I use light or if I use heat. But in this case, my first question is going to be, all right, remember, what is this reaction doing? It is replacing a hydrogen with a chlorine. It's a substitution reaction. So if I took 2-methylbutane and I said, what are all the possible products? And I'm only going to replace 1 hydrogen with 1 chlorine. So I'm talking about monochlorination. What are all the possible products that I could get from this reaction? And so what I would do is I would start and say, okay, for my first product, I'm going to replace one of the CH3 carbons with a Cl. So there's product 1, and I'm going to say, you know what, if I remove a hydrogen from one of those 3 hydrogens that I'm going to call A, I'm going to get product A. And then if I replace one of those CH2s, I'm going to get product B. And then I could replace the CH on the tertiary carbon, and I could get product C. And I'm not done yet, because then I could replace one of the hydrogens off of the CH3 group, the other CH3 group, and I could get product B or D. And then you might say, what about the other CH3 group? Well, if I replace a hydrogen with a chlorine on the other CH3 group, what do I get? I get the same product D again. So actually I'm going to call both of those, I'm going to say both of those sets of hydrogens are D because they lead to the same product. And so how many different products could I get from this reaction? I could get 4. Okay. And so when we first start this, we have to go through this kind of analysis. We have to say, okay, I'm going to replace each set of hydrogens with a chlorine, and then I'm going to determine whether that's a unique product because A through D all have unique IUPAC names. So how do you know if it's a new molecule or if it's a product that's already been written? You have to name it. So A would be what? 1-chloro-3-methylbutane. B would be 2-chloro-3-methylbutane. C would be 2-chloro-2-methylbutane. And then the other one would be 1-chloro-2-methylbutane. So I have 4 different products. Usually at this point, if we were, I would give you that and I would say, tell me how many products you have, and the numbers would range anywhere from like 2 to, I don't know, 1, 2, 3, 4, 2 to 5 usually. And then we'd go through and recognize that the 2 CH3s on the right-hand side give the same product. So that's kind of our first step if we're going to write the product of this reaction is I need to know what all the possible products are. But whenever we have multiple products, what happens next? My next question is, which product is the major product? And which product is the major product? It depends. On what? What does it depend on? Well, it's going to depend on whether I use chlorine or bromine. It's going to depend on whether I do this reaction with light at room temperature or whether I heat it up to 300 degrees Celsius. So this is like the worst kind of reaction because the major product, it's the worst and the best kind of product, or worst and best kind of reaction because from a synthetic point of view, if I can change the major product, then I can take this reaction and I can make whatever I want. I just got to change the conditions. But from a standpoint of being straightforward, that means it's not. It's not an easy reaction to just say, oh, it's that one. Now, you might go through and you might say, well, why wouldn't C be the major product? If you're thinking through that mechanism, where did C come from? C came from a tertiary radical. And you might say, oh, well, a tertiary radical is the most stable, right? The rest of them are primary and secondary radicals. So C is going to be my major product because it comes from a tertiary radical. Sometimes it is. But then counteracting that is, but wait, there are 6 hydrogens that give you product D and only 1 that gives you C and 2 and 3 that give you A and B. So based on the number of hydrogens, D would be the major product. True. Sometimes. So this is going to be a little bit more complicated reaction simply because sometimes it goes through the most stable intermediate. But now I'm going to throw in the idea that that Cl dot is floating around in solution. It's going to be more likely to hit a D hydrogen than an A, B, or C hydrogen, which is new. We haven't done that yet. So that's what we need to talk about next week on Wednesday. We'll do that after the exam on Wednesday. Okay, so bring your question. Well, I mean, don't bring your questions. Don't wait until Friday to bring your questions. If you got questions, throw them up on Piazza or come and see me, and we can go over, and I'll go over those. But otherwise, we'll answer questions on the Wednesday. I will take your topics review sheets, and we will go from there.